Hello everyone, today our topic is deep learning. Firstly, I will introduce a stochastic gradient descent algorithm. Here we just use this function as an example. Firstly, we just set some parameters. We just set alpha as a learning rate, delta is a parameter weighted to be optimized. Then we use this equation to update our parameter. Here is a training set generated by this function. Here you can say we just initialize some parameters. We initialize delta, alpha, limit, and limit is a threshold of error for stopping the iteration. Here we just calculate error. I think as for the code, I think the key things is this code. Here we can say we just randomly choose one sample with index j to update our delta. Because you can say as for the j, here we just generate j randomly. So in this code, in here, we can choose a sample randomly from the dataset. Now we run the code. You can see here are the results. Now we can, I want to say, if we lower the limit, if the performance could be better, run it, we can say we got a little bit lower error. It means the performance is a little bit better. Now I will introduce Adam algorithm. Here, same we just use this equation as an example. Here are the things about mass. Here, the momentum of the variable mt at timestamp t is the exponentially weighted moving average of the mini-batch stochastic gradient G. After taking the squares of the elements in a mini-batch stochastic gradient, we found G squared here and perform exponentially weighted moving average on it to obtain VT. After this, we perform bias corrections for variables MT and VT. Then here, we just update our parameter in using these equations. As for the code, samely, here we just initialize some parameters. Here we just calculate J, and the J is generated randomly. Here we calculate error. Here we calculate MT. And finally, we just use these equations to update our delta. Delta is a parameter weighted to be optimized. Then we run this code. Then you can say here is the result. Now we want to change a limit to say if the performance could be better. Now we can say the error is 998. Now if we lower the limit, for example, we change limit to this. If we run it, you can say we got a little bit lower error. It means the performance is a little bit better, right?
Here is backpropagate algorithm. We initialize our activation function seekboot and use these 4 steps in each iteration. Feed forward, output arrow, backpropagate the arrow output. And in our algorithm, the first function is used to calculate the mean error, and the second function is our sigmoid function. When derive is true, we got it returns the derivation of sigmoid equation. When it's false, it returns the original sigmoid equation. So the main part of our algorithm is a train function. We first initialize our weight matrix and we run it totally 10,000 times for each iteration. We first use feedforward to got the output of each layer, and finally we got our output arrow, and now we output the main arrow each 1000 iterations. In the backpropagate part, we use output arrow to get the output of the final layer, and use the backpropagate the arrow to get the output of the hidden layer. So we use this output as the weight matrix for our next iteration, just like what gradient descent algorithm do. And this prediction is used to check if our algorithm predict the data successfully. And here, let's run this algorithm. You can see it runs successfully, and then we add one more data. So, and here. It products a similar result. So with the increase of number of iteration, we got smaller error and a stable result. Thanks.